So first, let's jump into correlated subqueries. What is a correlated subquery? Well, a correlated subquery is when you have a select statement inside of another select statement. But to make it a correlated subquery, that select statement has to reference something from the outer query or the outer select. So if you put in your list of columns that you're selecting a query that references something from the outer query inside of parentheses and you have a select there, that's a correlated subquery. If you have a subquery in your where clause where some column value is in and then there's a select where it's referencing something based off of the outer query, that's also a correlated subquery. Now, what makes a correlated subquery different than a regular subquery is that they reference the outer query inside of the subquery. And what that means is that when it references the outer query, it means that that is going to be executed repeatedly for every row. And when I say every row, if it's in your select statement for the columns, it'll be executed in every row that's in your result set. So if you're selecting out 10,000 rows, well, that correlated subquery gets run 10,000 times. Where it's different is in the where clause. It gets run once for every row, but every row doesn't mean just those in your result set. Every row means those rows that have to be compared as part of that where clause. So if you're joining two tables with 50 million rows in each table, and you're using that correlated subquery in the where clause, or even, well, specifically there, then that could be run as many as n times, where n is the number of rows in that entire table that you're joining to. So it could be run 50 million times in that. So let's say you've done the best thing you can to performance tune that correlated subquery, and it turns out that you've got it down to like 20 or 30 milliseconds. It's really good. But then you take that 20 or 30 milliseconds and you multiply it times 10 million or 50 million or however many times it's being run. Well, it's not good at that point. And any amount of time you've got, if you're multiplying it by that many times that it's being run, it can't possibly be fast at that point. So the thing with correlated subqueries is that they're easy to do. And the common mistake that happens is they get overused. Basically, it's a way to go and get what you need without maybe looking at other options of how it could be done. Maybe instead of doing a correlated subquery, maybe you do a join to a table that has some grouping on it or something like that. The problem here is that performance can tank as the data set really grows. Think O of n squared complexity, meaning that if you've got n being the number of rows, and the more rows you have in there, it's taking on basically an n squared because it's having to be run perhaps on how you're doing a join that many times for each row in the queries that are being joined. Now, a lot of the time people look at it and think, oh, well, that's just one line in my query. How could that be run that many times? So what happens is the only way SQL Server can evaluate that correlated subquery that's referencing something from the outer table in the join is to run that once for every single row in that set. So the problem here is that you try it out in a small server or a new server or a development environment, something that doesn't quite have the same data that you have in production. And then over time, your production system grows and you get more and more data there. And what happens is that you end up with something that used to run really fast with a small amount of data that's now taking minutes or even hours to run, and it may tank the entire performance on your SQL Server. Now, think of this as someone built, here's a real world example that I was able to see with it. Somebody had a reporting query. This was going into an SSRS report. And in the where clause, it said where column A, I'm just making up names here, was in, and then a select from some other table where some value equaled something from the original table. And it worked great for years. And then they became more and more successful. They got more and more data in their production system, and that query just completely ground to a halt. And it was one of those things that it got to the point that somebody would run it and it would take down their entire, it wouldn't take down, but it would block up their entire report server. And then people would hit refresh and refresh and refresh again and again. and you end up with the same query running 2 times or 3 times or 10 times, depending on how many times they hit refresh in order to try and get it to run faster. Well, one of the ways that you can avoid this is to rewrite your query as a join. And I mentioned earlier that this is join months at Stedman Solutions, and go check out our join class or download our SQL join types poster for free. And that poster, just extra plug here, is available at stedman.us/poster. You just fill out a form and you can download the PDF. But the way you can avoid this is to rewrite your query as a join where possible, instead of doing like an in with a subquery, or even an equals with a subquery in your where clause. And what you want to do is you want to be able to test this often, test your execution plans to spot the issue early. And the way you can see this is to mouse over in your execution plan the different operators and see how many times it's being run. And in most queries, things should be run once or a couple of times, depending on how it's being done. But when you mouse over it and you see that a query is being run 50 times or 1,000 times or 10,000 times, a specific operator in that plan, well, that's a clue that maybe this isn't going to scale and maybe it isn't going to work well for you in the long run. So the key here is, if your subquery mentions the outer table, stop and ask the question of, could this be a join instead? Almost every subquery that I've seen could be written as a join of some type. And it might be a join to another subquery, but as long as it's not a correlated subquery, then it's only going to be run once instead of n times, where n is the number of rows being evaluated. Okay, so that's one that I have seen time and time again, that those correlated subqueries can really kill performance overall in a system.
Thanks for watching. I'm Steve, and I hope you've enjoyed this video. If you like it, please click the thumbs up icon. And if you want to subscribe, click subscribe to our channel and click the bell icon to get notified when we have new videos. All right, have a great day.